Hello and welcome to another video. Today we're going to be doing minimum number of taps to open to water a garden. And so in this problem, you're given a ranges array and you're given n equals some number. And essentially what you want to do is each one of these represents a tap, and the range is how far this tap can cover left and right. And you want to be able to water the whole garden from 0 to n with as few taps as possible. So for this first example, we can see that like this first thing is at index 0 and it goes 3 left and 3 right. So the range it covers is -3 to 3, and it shows you right here. So this is the first one. This is, or I guess this is the index 0 one technically. This is the index 1 one. And we have index 2, index 3, index 4, and index 5. You can see from the picture that index 1 actually covers the entire thing. So we want to just return one tap, because if we return this, this actually covers the entire interval from 0 to 5, which is what we want. Okay. So how would we do this problem? And it's a pretty tricky one, because the issue is with each like hose, it goes left and right. So if you did some kind of DP, and you started at some hose, you'd have to go left and right to all the possibilities. And it's like, how do I even do that, right? Like, how do I not just end up in an infinite loop? Like, how do I go from here to here, let's say, and then I don't come back because I cover some range? And it's also not as simple as being completely greedy, where you just always take the biggest thing possible, because just because you open a hose doesn't mean you want to skip everything else that hose covers. So for example, if we have 3, you can't just here's a good example, right? So let's say we have 3, and then here we have 100, right? And then we have a bunch of zeros after, 0, 0, 0, 0, 0. So the optimal solution here would actually be to, I guess it would be to take the 100 only, right? But the problem is how do we know that? Because how do we start at 100? And so, but you could see how just because if you take the 3, you're not going to want to skip the 100, even if you did take the 3, because you might have a solution where you have to take both. I guess technically maybe if they do cover each other, you might have to, you probably won't have to take both, but it's still kind of hard to understand. Even if you have this case, let's say the optimal solution is actually this, well, how do you actually get here, right? Do you just start at every single hose possible? Because let's say you start here, do I go back and then do I go forward? How do I not have an infinite loop, and so on? So the problem is this data is kind of not in the best way to work with. So we need to make this better. And so the way to make this better is, instead of actually using these ranges, we need to convert these ranges into these intervals. So we're going to convert these ranges into these intervals, and I'll show you in the code later how it's not super hard. You just min max, for example, for the left, you just say I can't go below 0, and for the right, it can't be above n, right? So if you have -3, this would just turn into a 0, and so on. But essentially, if you get intervals instead, so let's actually draw that out. And I'll show you kind of the intuition for the DP with that, and then the intuition for greedy, and then the optimal greedy solution. So we're going to take these intervals, but now we're gonna make sure that they can't be negative, because we don't care about anything negative. We only care about this part of the grid. So any interval that's negative, we'll just make it 0, and any interval that's above n, we don't really care either. If here this was 100, we don't really care. We just want to cover the area that we need. So we're going to have 0, 3. We're just literally taking these intervals and putting them over here. Except, like I said, we don't need anything below 0 or greater than n. So we're going to have 0, 5, 1, 3, 2, 4, 4, 4. And in this case, they are sorted. They're not always going to be. So you are going to want to sort it if you go with this solution. But essentially, you have something like this. And pretty much all you do for this kind of intuitive solution, and I can roughly tell you how you would do a DP. I haven't actually done a DP solution, but it seems pretty straightforward once you have it like this. So you have this, you have sorted, and now you literally start at saying so you have some result, which is your tap. So let's call that T. And then you have the intervals you're trying to cover. So let's just say we're trying to cover index 0 first. Let's not call it index 0, because we are going to index in this array. So let's say we just want to call location or something. Let's call that L. So we're trying to cover location 0, right? We have 0 taps used so far, and we're starting over here. And we need to make sure we cover every location from 0 to the end. So essentially what we're going to do is we're just going to go through these taps, and we're going to take any location, any interval that covers this location, and we're just going to take the biggest one. So that's going to be kind of like the greedy solution, and I'll briefly talk about the DP solution. So essentially for 0 to 3, so this does cover the 0. Okay, well, what about this one? This also covers the 0, but it goes farther, right? And then once we go over here, this no longer covers the 0, right? So essentially, we want to cover every location from 0 up until the end. So we're just going to start at the initial location, which is 0, and then we'll go to the end. So we're going to say, like, okay, well, we'd rather take this one, right? Because it covers farther. So what's going to be our new location? Well, we covered 0 to 5, right? So then our new location is 5. That's our new starting location. Okay, well, that's fine. So now the next thing has to start at 5, pretty much, right? Because we covered 0 to 5. I guess technically it would start at like 6, right? So it started at like 6. And yeah, so we covered 0 to 5, and then the next thing would start at 6, but then we're kind of like done, right? Because 6 is greater than 5. So then we're just going to say, okay, so we took one interval, and this is the interval we picked. And if you wanted to do the DP solution for this, essentially the only difference is you would, like intuitively, you would pretty much have to start at every single interval that starts at the 0 location. So like let's say it would look like for this. Essentially you would have the index of the interval, and then you would also have like I guess you only need the index of the interval, and then in the interval you would just loop from every single interval it can go to. And that's why you need this kind of interval format, because then you don't need to go backwards. Notice here, you can just start at 0, and then you only go forwards. Same thing here, same thing here. You don't need to go backwards, right? So essentially what you would do is something like you would start at these locations, and then you would loop to every single place you can cover. So like here, here, or here. And then every time you go to one of them, you would add 1 to your answer. And then if you can get to the very end, then you would get a solution. And that would be something like n times... So I think in these constraints, the numbers in here are n to 100. So it would be something like n times 100, somewhere along those sorts. But we're going to do something better. And so for the greedy, also keep in mind, this is n times 100, but it's also n log n, right, to sort. So it'd be like n log n plus n times 100, something like that for the DP. And for the greedy, where we just literally take our, best thing every time, that would be n log n. Because essentially we are just sorting, and then we're just taking our best number every time, right? So that part is pretty straightforward. So what we need to do now is we need to actually figure out, like, where do we go from here, essentially, right? So that's what we need to do. And yeah, so for the greedy, like, pretty straightforward. You literally just, at every single interval, you take the best one you can. And let's actually show the greedy with a better example, because this one's not the best, right? Because it's like you just take this and you're done. So let's actually go through another example of this one, and it will demonstrate it better. And let's make these intervals. So 2, it's going to be pretty fast as well. So, okay. So essentially we'll draw out the indices as well, just to make it easier to make the intervals. 4, 5, 6, 7. So essentially we need to make intervals out of these. So pretty straightforward, right? So the first interval starts at 0, goes to 1. Like I said, we don't care about negative numbers. Second interval starts at 1, and it goes 2 in each direction. So that's going to go to 0 and 3. Third interval starts at 2, goes 1 in every direction. So that's going to be 1, 3. Fourth interval starts at 3 and goes 0 in each direction. So that's going to be 3, 3. Fifth interval starts at 4 and goes 2 in each direction, so it's going to be 2, 6. And this will make it easier to figure out the last solution. So 5, so it's going to be 4, 6, 6, 6, and finally 6, 7. Remember, we don't care about any intervals that are negative, so we'll just make those 0, and anything above 7 we also don't care. Okay. And so we're going to do the same kind of thing, where we're going to have this location equals 0, our number of taps that we turn is going to be 0, and then we're going to start over here. So once again, we need to go through every interval, and we need to figure out which one do we take, right? So in the beginning, we need to go through these intervals, and we need to figure out, like, okay, we need the biggest interval, the one that goes the farthest, that takes up location 0. So this one does, and ends at 1. What about this one? This one also does, and ends at 3. What about this one? This one does not. So we're going to take the biggest one we found. So that one ends at 3, right? Okay, so that's fine. So now we need our new location. So if it ends at 3, and you can do this a few ways, but essentially, if it ends at 3, you need your new interval to be where? You need your new interval to be here, right? So this will end at 3, and we're going to write, okay, we ended at 3. We used one tap. Now we need our new interval to start at 3 or 4, right? 4 is also fine because we ended at 3. So it needs to be at 3 or 4. Either one of those would be fine because then that would cover the entire gap. So sorry, it wouldn't be 3 or 4. It would be anything below. It would be anything 4 or less, right? Because the last one we covered so far 0 to 3. That's the area we covered, right? By taking actually, I think we did screw this up a little bit. Yeah, we did. So we actually needed to take this interval here, right? Yeah, we need to take this interval here. So that's the one we took. So we took one here, and then, but that still went to 3. So we covered 0 to 3. So now we need our new interval to be anywhere we want, but it can't be past 4, right? Because we need to cover 4 now. 4 is like the next thing we need to cover. And so this one, does it cover 4? Well, no, it does not, right? So this one wouldn't work. Does this one cover 4? No, it does not. So the 4 is like the next thing we need to cover because it's the one after 3. So we can even write it like this. Does this cover 4? Yes, it does. Okay, so that's valid. It ends at 6. Does this cover 4? Yes, it does. It also ends at 6. And does this cover 4? No, it does not. So we're going to take one of these. Doesn't matter which one. It's going to end at 6. So if it ends at 6, our next location is going to be 7 that we need to cover. And then we took 2 things now. And now we need to cover 7. So does 6, 6 cover 7? No, it does not. And does 6, 7? Yes, it does. And then that's the one we take. And notice if you took this and you took, which one was it? This, or one of these, doesn't matter which one. And then you also took this, that's 3 taps, and you covered everything, right? We covered 0 to 3, 4 to 6, and 6 to 7. So that would cover everything. So this is kind of like the greedy solution where you're literally just trying to cover, you keep updating your location to the farthest interval you can cover that also covers your original location. And let's do one little thing here, one more thing that we can notice. So let's say we couldn't cover everything. Like let's say we take out this and we take out this. Now what would happen? Well, now what would happen is we would cover 0 to 3, right? And then we would try to cover 4 and there wouldn't be anything to cover it. So then if you have some new interval and you don't have anything to cover it, then you would just say like, okay, well, we're going to return -1 because we don't have anything in here for 4, right? So that's how you would figure out where your taps is no solution. But the problem with this is A, we have to sort, right? And B, we have redundant intervals, as you can notice. So let me actually, if I can go back, I guess I can't, but that's okay. Even here you can see that, right? Like if we have these 2 intervals, when are we ever going to take this? 2 intervals that start with the same place, we would never want to take this, right? They start at the exact same place, so this one's always going to be better. So that's redundant. And we're going to have a bunch of these, right? Like, we never want to take an interval that's smaller than something that's, like, we're never going to want to take this over this, for example, right? We're always going to want to take the interval that starts. I mean, here it doesn't really matter. Like, this one, they both might work. But essentially, if an interval has the same start location, you never want to take a smaller one. It doesn't make any sense, right? You're never going to want to take this. There's no benefit. So that's kind of like the trick to the second greedy algorithm. And the second greedy algorithm is going to say, okay, we never want intervals like this over intervals like this. Like, they might not matter, but this will always be better or equal, right? Because, and the same thing with like intervals that start with the same number. So I don't know how this 3, 3 got here, but yeah, essentially, you're never going to want intervals like that are smaller. It doesn't make any sense. That start at the same exact place. So if 2 intervals start at 0 and one goes to the end, why would you ever take a smaller one? It doesn't make any sense. So that's the intuition we are going to use to do our final greedy solution, in which case we will actually make an array, and it will be all zeros. So we will, and basically a 0 just means like there is no tap that's there. So we're going to say we care about 8 locations, right? So we're going to make 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. And essentially, these are going to be indices once again. So 0, 1, 2, 3, 4. And now pretty much for these intervals, we are just going to go through, we're going to do kind of the same thing. So maybe we should have had these intervals, but that's okay. We can just do these in place. So essentially for all these intervals, we're going to say like where do they start and where do they end? And then we're going to update these. So this represents the start locations, and then we're just going to save the biggest end location, right? Because if a bunch of tabs start at 0, you only care about the biggest one. You're only going to want to use the biggest one. There's never a reason to use anything smaller. So let's just go through that. So this 0 ends at 1. So this means it's length 1. So let's just use that, and let's actually change the font, or not the font, but the color. So this is going to be 1. Now this starts at 0, and it ends at 3. So now we have something that starts at 0, ends at 3. So we're going to update this to be a 3. Now this starts at 1 and ends at 3. So we're going to update this also to be a 3. Okay. Now this starts at 3 and ends at 3. So we're going to update that one, right? So if it starts at 3 and ends at 3, that means like it ends at 3. So it doesn't really go anywhere else, right? And so if that's the case, then, or actually, sorry, so it would end at, no, this is length 0, right? So length 0 means it doesn't go anywhere. So it starts at 3 and ends at 3, so it's length 0. So we're just going to leave it just like this. It's going to be length 0. Actually, I guess technically it would be like end at 3. So it would be like this, technically. Right? So it starts at 3, ends at 3. Okay. And then for this, it's going to start at 2 and end at 4. Well, we have a 2. Or actually, it's going to start at 2 and end at 6. Sorry. So we have 2 and at 6. And then this one is going to start at 4 and end at 6. So start at 4 and at 6. Okay. And then this is going to start at 6 and end at 6. So this must be 6 and 6. Does anything start at 5? I don't see anything yet. And so something not starting there means like you can't really get there as well, right? So yeah, so we only care about like the starting locations essentially. Okay, and this starts at 6 and ends at 7. So that's obviously longer, so we're going to update this to be 7. Okay, let's just double check this one more time, just to make sure we have everything right. So this one starts at 0 and ends at 1. That's okay. This one starts at 1 or 0 and ends at 3. So that's correct. We updated that. This one starts at 1 and ends at 3. So that's correct. This one starts at 3 and ends at 3. Okay. This one starts at 2, ends at 6. Starts at let's see. Starts at 4 and ends at 6. It does get a little confusing. That's why I think this one is a little tougher. This one starts at 6, ends at 6. And then this one starts at 6 and ends at 7. Okay. So now for our intervals, now essentially we're going to be doing kind of the same thing, but now we have this. And notice how we didn't need to sort. Like we could just go from this to this in n time, right? So we have our intervals, and essentially these zeros mean there's like nothing here, right? And so that's kind of the thing, is like this wouldn't be updated. So now let's go through this. So I guess technically, yeah, there's nothing that like starts at 5 and ends at 5, right? So this would be zeros essentially, pretty much. Yeah. Okay. So let's go through this one now, and let's figure out like what would happen, and if I screwed anything up, but hopefully not. Okay. So we're gonna start at location 0, and our taps is gonna be 0. So we're gonna do the same thing. We need to start at 0. So where are we gonna go, right? Like if we need to start at 0, we can simply look. Okay. Well, we are here. So what's the farthest number we can go to? So we can go to 3. Okay, so our new location is 3, but it's actually going to be, yes, it's going to be 3, and then we use 1 tap. And so then, afterwards, we need to start at location 4, right? So we're going to look for anything that covers location 4. This is the one we need to cover, right? Because we covered 0 to 3 so far. We covered 0 to 3, now we need to cover 4. So is there anything that covers location 4? Well, let's take a look, right? So we're not going to obviously take this one, but we're going to start here. So we're going to say, okay, well, this starts at 1 and ends at 3. That's no good. This starts at 2, ends at 6. That covers location 4. Okay, what about this one? This starts at location 3 and ends at 3. Okay, that's fine. And this starts at location 4 and ends at 6. That's also fine. And this one is no good, right? Because it starts at location 5. So it's between this one, and doesn't really matter, like I said, right? Because they both end at 6. But essentially, you would add another one here, and then this would be location 6 now. And so now we covered location 0 to 6. Now we need to cover location 7, and we are over here. So this starts at 5, and there's nothing here. So essentially, I think you might be able to say 5 and 5. No, but I think you just have to skip these. And so we'd skip it. And so here we have location 6, and it ends at 7, which is what we want, right? We want to cover location 7. So that would perfectly work. So we could take this one, right? And that's the one we are going to end up using. And then this would be 3 now, right, for our thing. And then we would be done, because now we need to cover location 8, and then we're out of bounds, right? So 0 to 7. So essentially, this is like the greedy. And basically, in the greedy, you just do this in place. And I'm pretty sure, I think these zeros are zeros. I will double check my code. But yeah, I think these zeros are zeros. So essentially, you do the same thing. And then let's look for a no solution type of thing. And let's see if we also get a no solution. So let's just say we got rid of some of these. Like I said, it would be a lot easier if we had the intervals still. But let's just say we don't. So yeah, I think probably as a default, you probably do want to set them equal to each other instead of 0. That would probably be a little bit better, just so they don't move. I think that would make some sense, but I think 0 would also work, right? Yeah. Okay. Yeah, because essentially you're maximizing. So even if this was 0, yeah, okay, I see. So the reason it doesn't matter, like you could set these equal to the same, but the thing is we're going to be maximizing at each of these. So whenever we have, like, let's say we are here and we need to look at like 5, we're going to be comparing this to 5, and we're going to take the 5. So basically what will happen is the 5 will never move. So this is fine setting these to zeros, because we're going to be maximizing our like new location. So it doesn't matter that this is 0, because these values will just never be used. So it doesn't matter. And like, yeah, okay. So that does make a lot more sense now. And so yeah, essentially, if some of these weren't in here, then it would break. I guess we can show that. I think if we got rid of these, so if let's say these are all zeros. So let's just do 0, 0, and 0, and let's just make sure that this breaks. Okay, so we'll start this again. Location 0, result 0, or I guess T0. So we would start here, and we would say, okay, well, this one's fine. So this is the one we want. This one doesn't work, right? It doesn't cover the 0. So this is the one we want. As soon as we get one that we don't want, we can just stop. But yeah, so this is the one we want. This goes to 3. Okay, we use something. Okay, now we need to cover location 4, right? We need to cover location 4 to move our thing up. Well, let's see if we can do that. So this does not cover it, right? Because like I said, we're going to be maximizing. So we're going to maximize 0 and 4, so we'll just get 4. Or I guess, sorry, we're going to maximize 0 and 3. We need to actually get a 4 here. So our result here will be 3. So we're going to just like say, okay, is this a 3? Like 0 and 3 is going to be 3. And then here, we're also going to say, okay, 0 and 3, right? 0 and 3. And then this is out of bounds because this is greater than location 4. So you see like this didn't really move at all. So this is fine leaving these at zeros, and I'll show you in the code. Okay, but that's pretty much it though. So you literally can go from like a n log n sorted interval to a n greedy, where you literally just say like, I'm just going to take the biggest possible, the longest possible tap from any location that covers whatever the new value I need, right? So if it ended at 3, the new value I need to cover is 4. So anything that covers 4, I'll take, and then I'll take the longest one that covers that. It's kind of like a jump game 2, I think, but it's like a little bit trickier. And yeah, definitely if you started with a DP solution, I can see how this could be a hard problem, because you know your stuff is going left and right, and you're like, how do I not loop? And the way you would not loop is use intervals instead. Okay, so let's actually code it up. So we are going to make these intervals. So we're going to say, and we are going to make these intervals, like I said, we're going to make everything equal to 0, and then we're just going to update values later on. So we're going to say this, and then we are going to actually loop through our ranges. So for I in range length ranges, we do need the index, I believe. So okay, so we're going to make a left and a right boundary for the interval. So we're going to say left equals, remember, we don't want a negative, so we can just maximize it with 0. So it's going to be I minus ranges I. And then that way, if it's negative, it'll just be 0. And if it's above 0, it'll be above 0. Same thing for the right. We're going to say we don't want it to be above n, so we're going to say min n and then some value. It's a little trick that you can use. Okay, and now we are going to actually set the interval. So we're going to say intervals left And so intervals left is where it starts, and we want the biggest right value we can have, right? So we're going to go through all of these, and then we're going to have a bunch, we might have multiple right values for the interval, so we're just going to say let's maximize that. So let's just take the current intervals left and the right. So whatever the left is for this right value, let's just see if this right value is bigger than what we had before, and we'll just maximize that. Okay? And now we're going to have the index in the intervals that we're traversing through. We're going to have the taps, and we are going to have a start index, right? And so we can just say while start is less than n, because when you get to n, you're done, pretty much, right? Like when you covered n, you're done, because start index is going to be everything you covered. So when you covered 5, you're done, okay? And we're going to have a new start value, which is going to be start, and then we're going to be updating it, and then we're just going to use that to check in the end, did it actually move? So while I is less than length intervals, we can just go through the intervals, and this is why it's a n approach, because essentially every time you stop, you just start from where you stopped, right? So if like this is an invalid place, then you would just say like, okay, let's just start back up from here. So you're not doing like n squared, you're literally just going through your array one time. So and I is less than or equal to start, right? We want to make sure that the I value, so for example, if we're looking at index 3 or 4, we want to make sure that we actually don't have a value bigger than that. Otherwise, that's not going to cover it, right? Like if we're trying to cover index 4, we can't start at 5. You know, that wouldn't cover it. So new start equals max, and this is where we just maximize the farthest we can go. So we're going to say, okay, let's just go to new start. Let's try to maximize it, and where can it go? It's going to go into intervals I, right? Because now we just, in this picture, we just have, here it used to be 2 numbers, but now we just store 1 number. So whatever is valid, let's just take that number. And that's why I said these zeros don't matter, because we're going to maximize with the new start. So if like this new start starts at 4 and our number is 0, it's going to stay at 4. Okay, and then we do I plus equals 1, right? So once we look at that, we're going to keep going. And then if new start equals start, that means we didn't move anywhere. So if we didn't move anywhere, we don't have a solution, right? We tried to look for a new biggest location for some index, and we couldn't find anything. That means there is nothing that covers that. So if that's the case, then we're just going to return -1 because we can't cover that area. Otherwise, we're just going to update the start to be the new start. And we are going to update a tap, because every time we find the new location, that's going to be a new tap. And we are going to return taps. Yeah, let's see. Okay, so you can see it's about as efficient as you can get for this problem. I mean, I can do it a few times. There might be like some small optimizations, but other than that, it's about as efficient as it gets. Okay, and so let's go through the space and time here. So for the time, it's going to be, so we make these intervals, which is n time, right? Then we loop through the ranges, which is n time as well. We make this stuff, so this is all n. And then we are actually only looping through the intervals 1 time here, so that's n. And then, yeah, so basically it's just all n time. We're only looping through the intervals once here. We're looping through the ranges once here. And then we're looping once here. So it's going to be like something like 3n, which simplifies down to O(n). And for the space, we do make these intervals. So that's going to be O(n), right? So we did make this array here of every single starting point and the farthest you can go. But yeah, I'd say for the greedy, for like this optimized greedy, it's probably something that you can't really come up with in an interview, but you can, at least I kind of showed how you get the intuition from it, right? By just doing normal intervals. And then from the intervals, you just see your redundancies. Like, hey, if I have multiple intervals, I'm never going to take the smaller interval that starts at the same point. It makes no sense. So that's essentially the only optimization you're making, is you're doing that, and then you're realizing, hey, instead of sorting them, I'll just write down every single tap that starts at some location, and I'll just maximize the farthest it can go, because that's the optimal solution. And from these intervals, you realize, hey, I just want to take the biggest one every time. That's the best thing all the time. And then if I take something and then there's nothing else that covers the next point, that means I have no solution, because I took the biggest possible thing that covered the point I needed, so there's nothing better than that. But yeah, I think greedy problems are definitely not super intuitive and definitely hard to come up with on your own. But I guess this is why it's a hard problem. Like when I first looked at it, I was like, oh, super simple. But then I realized you can start going backwards, which kind of make this hard. Like if this problem literally said, you know, your range was like 0 to like I, let's say. So for example, if like 3 meant this can cover 0 to 3, then this would be like a medium problem, right? Because it's like a really easy DP at that point. So the fact that you can go backwards and realizing, hey, I need to actually use intervals instead of just this, because otherwise I end up in kind of a loop where I'm going back and forth all the time, makes it a hard problem in my opinion. Definitely much harder than like the last few hard problems we had, which were kind of like a medium problem. I think this one definitely is a hard one. So, but yeah, that's going to be it for this video. Hopefully you liked it. Definitely kind of a long one, but kind of showed you all the steps from DP to greedy to optimize greedy. So hopefully you did enjoy it. And if you did enjoy it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.